Hey, when I make cabinets on my CNC, I have to screw my plywood down. And I know that I've done videos before about how I do cabinets with my CNC. This one's going to be different. Honest, it's going to be different. What I'm going to cover more in depth is how I design all my cabinets and the software that I use. Now, I use Fusion 360, and I use it for a couple different reasons. Number one, it's got design capabilities. 2, it's got cam abilities. Camability? And number 3, the cost is pretty reasonable. Oh, wait a minute, there's a 4th reason. It's got G-code capabilities. When you design cabinets on a CNC, you have to create G-code. Let's take a look in Fusion. Here you're going to see my extensive library that I have that I've created over a couple years. That's by far the most work that you're going to do in Fusion is when you create your library. Now that you have a library, you can create parameters. And take a look here in Fusion, you can see the different parameters that I can set, whether it's width or height or depth of the dado, width of the dado, thickness of the side. It's just unending. And then you can go in there and you can change, like this. For instance, I just changed the width and voila, my cabinet goes from being 36 to 24. And it's all parametric, which means all the parts, when you make this bigger or smaller, are going to be exactly the size they need to be. And what's nice about when you create your library, you can create cabinets that have different configurations, whether it's 1 door or 2 doors, or it's a drawer stack, or if it has scribes on the end. You can create all kinds of variations. And I only leave the parts on that I know that I'm going to use or that I'm going to need. So now that we have it all designed, let's go ahead and take a look and see how we lay this out for the CNC. First thing I do is I draw a 94 by 46 sheet of plywood. This gives me exactly 1 inch all the way around to allow for screwing down. I'll go ahead and extrude this to like 1 inch or something just to make an imaginary base, and I'm going to use this to align all my other parts up to. Once I make my base, I go ahead and insert a cabinet that I want to do, or a couple. And you have to break the link on these because any changes you make in here will make it on the original part as well. Now that the link is broken, we can go ahead and move all these parts wherever we want. Just make sure that you're moving bodies and not components, because if you move a component, the whole thing's going to move. We just want to move the bodies one at a time. And we're just simply using the move command to move every different body. Now here we've got the back, which is 1/4 inch. We're just going to take that off and move it out of the way. It won't even go on this sheet. Now all we have left to do is arrange this for the best cutout that we can on the sheet of plywood. And then we're going to go ahead, after that's all done, and line everything up to the bottom sheet, or the fake base that I made. Now it's critical that you align all the tops or all the bottoms together so that we get a consistent dado depth. You also want to make sure that you have adequate spacing between your parts and alignment so that you don't put the end mill through a screw. I make sure that I have 1.25 inches between each piece to fit the end mill. I'm just using the alignment command and the move command. Once it's all lined up and you're happy, you got to go to manufacturer and you have to create a setup for your new sheet of plywood. And you notice it picks up every body that's in there, and we don't want all the bodies, we just want these that's going to be on this one sheet cutout that we're doing. We also want to make sure that our origin is down in the proper corner. This is what a 21 box job looks like with 17 3/4 inch sheets and 6 1/4 inch sheets. Every sheet gets its own setup. Another good thing about CNC machining, pre-drilling. I use a 1/8 inch end mill to pre-drill all my holes. Not just screw holes, but these little alignment marks or peck marks that I use for drawer guides. Back on the big multi-sheet job, you'll see that I go ahead and I choose all the little pre-drill holes right here. And I just go ahead and attach that 1/8 inch, and I manually set the height because the depth is not important when you're just doing screw holes and little peck marks for drawer guides. Once I have all the 1/8 inch holes pre-drilled, I come back and I use this 5mm end mill to pre-drill all the shelf holes and hinge plates. And I lay all those out. Here you can see I can have a left door and a right door, or if I don't need one, I just go ahead and don't mill that when I make this piece. Back here on the big job, you can see all the 5mm shelf pin holes that I'm going to make, which saves me a ton of time. And probably the nicest thing about CNC milling is using this. A 3/8 compression end mill. First I lay out all my dados. That's just going to take a 1/4 inch pass on all these lines. The second operation with a 3/8 is going to be cutting the rough out borders. I have to do this in 2 passes because my CNC or my spindle is not strong enough. So I do a rough cut and I make it in 2 passes of 3/8 of an inch, and I leave 2 to 4 hundredths on each pass. I use 1/8 inch tabs to hold everything in place while cutting. To make the final cutout operation, I just duplicate the rough operation, take out the multiple passes, and I take out the stock to leave. With the 5mm and the 1/8 inch, I just manually set the height, but I use my touch plate to set the 3/8 because it's critical for the depth and height of the dados. And this is what dado cutting looks like without the dust boot, which is really dusty. Yeah, at 4 times speed. Once the dados are cut, we go ahead and put the dust boot back on. Make our rough cuts first, remember, leaving 4 hundredths, and then we'll come back and finish up with a single finish pass. This at 15 times speed. Best laid plans. Carbide bit right through it. And then we go ahead and unscrew the whole thing. Little peck marks for the drawer guides where the screws are going to go. Here's an up-close view of the drawer stretcher dado and the dado along the bottom for the deck. I need to go through the shaper with my flush trim bit and get off any little imperfections on all the tabs. Now you can send your manufacturing layout to a drawing, and then you can mark every part which one it is, so when you get the huge stack of parts, you know what's what. Like all these, and all these, and all these. Oh boy, new tool in the shop. That's my next video. What's this? A trimmer as well? Oh, stop. So nice putting door hardware on and drawer guides on when the box isn't built. And from here on out, it's like building a piece of IKEA furniture. We just give it some temporary tacks to hold it in place with the nail gun, and then finish screwing it off through the really cool screw holes that I made. And eventually, all the parts make all these boxes. Building cabinets on a CNC has a lot of benefits. I figure each sheet is going to take an hour to cut out. That's because I don't have a high-end CNC. A high-end CNC could cut a sheet out in about 15 minutes. But the efficiency comes in that while the sheet is cutting out, you can do other things like band, you can put the boxes together, you can prep all your doors. Theoretically, as soon as all the sheets are cut out, you can put all the boxes together. My calculations were that it took me 24 hours to cut and build a 21 box job. It's like having 2, well, 1 3/4 old guys in the shop at the same time. One of the biggest advantages of working on the CNC is you design everything in CAD. That means I can order all my doors and drawers before I even build the boxes. As soon as I have the boxes complete, I just pop in a drawer. And it fits perfect. Same with the door. perfect fit, and a drawer face. So I hope you liked this video. Watch these. We'll see you next time.